Hello, everyone. So today I have a very new topic. Would like to share my experience when it comes to system design and its world, or you can say an ecosystem. So system design, this is a very important topic when it comes to any interview when we are trying to design a system which is highly scalable, uh, resilient, fault tolerance, highly available, low latency, throughput, and there are many things which are uh, connected to system design interview questions, right? If we talk about FANG, like all the big giants, they have good number of interview rounds which are uh, completely based on your system design skills, like how you think, what is your approach, the way you are analytic, like the analytics of your reaching to a particular solution, and things like that. So I know, like, people and most of the folks, they usually prepare a lot in when it comes to like designing component diagrams, high level, class level diagrams. But those things, I think they are pretty straightforward. I do not think any complexity. For example, let's say you are using draw.io or Miro, any tool where you can use the utilities to design your component, like you can design rectangle or arrows and all that, like those diagrams, they are pretty straightforward. And I think one or two uh, practice for system design problems, you should be easily able to get a confidence on that. So but the problem here is, like, we must understand the fundamental concepts which should give us the idea about how we are planning to design the component, like what are those key elements, what are those key concepts which we will use, which will backfill, or you can say which will be as a fuel, would be used to give us an idea, like to give a trigger point to the brain that, hey, this is the problem and I need to design a high level diagram on this, so I'm gonna create these components and things like that. But see, as I said, important concepts, they should always be there as your fundamental pillars for any system design problem. So I would cover those things here in this particular session, system design cheat sheet. Okay, so let's start with understanding the problem scope. Ask clarifying questions. So what exactly? So any problem you have, for example, any system design problem you have, these are the important clarifying questions which one should always ask. For example, data type. Is it logs, video files, images, text, and what? Right? So this is also very important. Unless you're not sure what is the data type, you won't be able to find out, for example, the scalability, because scalability depends on your data, right? How much data is coming in or streaming in, how much data you're planning to archive, like for your archival storage or in real time streaming. So it is very important. Then scale, how many users, transactions, or data points are generated. For example, your question should be aligned for whichever problem statement you have, like how many users per day, per month, or yearly. We should target all these numbers in advance, right? And put those notes in front. Retention. So how long should data be stored? For example, for any system design problem, if there is no retention policy, is it good or bad? These are the clarifying questions one must ask. So data retention for some system design problems could be 1 year, and maybe there are some cases wherein your data need to be there indefinitely, right? So retention period is also one of the important thing. Then compression. Compression is something which is very important, and I would say most of the problems where there are need for optimizing the storage, compression is something which can come in rescue. So is data compressed before storage, or are you planning to do the archival or compressing the data before storage? If yes, then yes, we are going to consider this uh, basis the trade off or the requirement of the particular problem. So I would say you should highly, have these points somewhere in some corner of your brain, so that whenever you got any problem, these are the generic points that you can always have, like data type, scale factor, daily, monthly, yearly, retention period, like how long should data be stored, and then compression. right? Do you need compressions or not? So yeah, that was something which was connected to understanding the problem scope, and it should always be generic points. You can correlate all these points with any problem you have. Okay, so moving to the next, use common data size estimates. I think most of the time discussing about when we start discussing about uh, the size estimates, for example, we should always have some rough estimates in mind for common data type. So this is also something which you can learn, right? Because you should not waste your time while you are doing the interview and explaining the size estimates. So for example, text oblique logs. So one log entry, you can be correlated to approximately 1 kilobytes. Similarly, images, compressed JPG or PNG images, so it can be from 200 to 2 MB. So that is the standard, you know common size of images. So it can start from 200 KB to 2 MB, okay, which is a compressed JPG or PNG version. Videos, so HD video, when we talk about, so it costs around 1 GB of data per hour. So let's say video is coming, so an hour of video will be around 1 GB storage. So this is also a standard that you can learn. Whenever there comes any video related question, you should always have this. Okay, we assume that, let's say, 1 hour video is equivalent to 1 GB of data storage, and that would be enough. Similarly, audio, so audio, all the mp3s, they can approximately be correlated to 1 MB per minute. So 1 minute video audio, if you are playing, then the size, standard or normal size, or the common size, which is very popular, is 1 MB. Database rows, you have Oracle, you have many databases in place, right? So whichever is record you are storing in the database, so usually depends on the schema, but on an average, the standard size for a row is 1 KB. So now these are also very important size estimates that you can learn and you can remember or memorize for your interviews. Like text and logs, one log entry, 1 KB, database rows, 1 KB, audio, 1 minute, 1 MB, videos, 1 hour, 1 GB, images. If it is a compressed image, it will start from 200 to KB to 2 MB. So yeah, that was something which I thought to share when it comes to the size estimates, like common data size estimates, which are very popular and standard, or you can say generic size estimates, which you can use across any problem which comes on the data system design problems. Coming to the next, uh, apply approximation formula, right? This is also very, very important. So see, whenever you start playing with this, like for example, previous slides will give you numbers about like how much data you need per log entry, per row in a database, and then video size, which is 1 hour, or let's say audio size, which is 1 MB for per minute. Now you have to calculate the total data size. Okay, so total data size, it's a formula, very simple formula, size per item. So what is the basic unit, the atomic unit that you're going to consider in your size estimation? So size of that unit, that per item, multiplied by the number of items, multiplied by the retention period. So this will be the total data size that you will be needing for that particular retention period. So for example, let's say log storage for a web application, a very common example, right? Because we know we have logs for every web application which is running. So let's say on an average log size is 1 KB, right? Now, request per seconds are 1000 request per second. Retention is 30 days, right? So if that is the assumption, or let's say that is the general case, now what we have to find, we have to find the total data storage for 30 days when situation is like this. So logs per day, first we have to find how many logs per day are there. So logs per day would be 1000 RPS, because these are number of requests per second. So what you have to do, 1000 RPS multiplied by 86,400 seconds per day, because these are the number of seconds which are there in one day. So you should also memorize it, like one day, how many seconds, because second is the very common unit that we always play around. So 86,400 seconds per day, and let's say per second we are getting 1000 requests. So the total logs per day will be equal to 1000 times 86,400. So it will be 86,400,000. So roughly, approximately around 86 million logs per day. Now, data per day. So logs per day is something you got 86,400,000 logs. 86 million 400,000 logs per day. Now, when it comes to the data requirement, it is again something which you have to calculate. So, what is this? Data per day would be number of logs per day multiplied by size of each log, which was 1 KB, the average standard that we have set. So, multiplied by 1 KB. So, it will be total 86,400,000 kilobytes, right? So, it will be 86 GB per day, because again, you must know that when it comes to KBs, so when you have 1000 KBs, it is 1 MBs. When you have 1000 MBs, it's 1 GB. So now you can just see here, these three dots, you can just say this is, you can correlate it with, 1000. And then another, these three numbers, you can correlate with another 1000, right? And then you will be having like two digits here, and then one here, and then one here. So again, it will be 8 and then 6 and then one digit here for this. So it will be 8,600, something like that, right? So it will be 86. It is over here, it will be 86, and then you have million here, then it will be GB, right? So you should know, you must always know that whenever it comes to the GB calculation, so you must know that this 1000 is an approximate number which you can put anywhere. So 1000 KBs is equal to 1000 bytes is equal to 1 kilobyte. 1000 kilobytes is equal to 1 megabyte. 1000 megabytes is equals to 1 gigabyte, right? And 1000 gigabytes would be 1 terabyte. So something like that. So that's how you actually play around with your with your data storage. And then total for 30 days. So it will be like, you just multiply it by 30. So 86.4 GB per day, it will be 2.6 terabyte uh, per day. So again, when you talk about numbers in terms of thousand, it will be very easy for you to come to a conclusion whether it will be a GB, MB, or um, or a TB or a petabyte. It could be any other higher number. So yeah, I think that's pretty much clear. So anytime when you have any data estimation, you must know what is the unit, the atomic unit for your whatever data items you are going to calculate the size for. You calculate the size for that atomic unit, and then you try to find out request per seconds, because always try to play with seconds, because that will be easy for you. When it comes to systems, they talk in seconds, they do not talk in minutes, or they do not talk in hours, right? So it is all about in seconds. So you should always take your basic unit for time as seconds. So yeah, that's pretty much all. I think you got it. um, so let me move to the next slide. Prepare common use cases. So this is also something that you can always memorize for your data structures, data system design interview questions. So 1 million log entries per day is what? 1 GB per day, right? So 1 million logs. So that is a rough estimate. How 1 million logs is 1 GB? 1 million logs. So when you 1 million logs is equal to 1 GB, and if you just think how, so you must understand again those zeros in the expression. So I can explain you in a very simplistic way. So 1 million logs, okay, which is 1 and then 60, is equal to, let's say if it is 1 day, 1 million log for 1 day calculation would be 1 million log multiplied by the size of 1 log. So let's say we say 1 kilobyte size for 1 log. Okay. So in that case, what will be the number? So it will be 1 million multiplied by 1 kilobyte in size, right? So then uh, the number that comes around to be would be 1 GB. Why? So, for example, when you have 1 and then 60, all right, then multiplied by 1 KB is equals to 1 GB. So, you calculate um, like number of zeros here. So, number of zeros, as you know, 1 KB is 1024 bytes, right? And then we have 1 MB, which is 1024. So I always take approximate. I do not say 1024. I say 1000. So 1 MB, 1000 kilobytes. 1 kilobyte, 1000 bytes. Similarly, 1 gigabytes, 1000 MBs. So this means 1 gigabyte would be equal to 1000 multiplied by 1000 multiplied by 1000, correct? So these will be the total number of bytes. So now if you just do that, you will come to a number which will be somewhere around uh, 1 million. Okay, so why I say 1 million is because uh, l- 1 million multiplied by 1 KB is equal to 1 million multiplied by 1000 bytes, and then it will be 1 million, and then of course 3 more zeros. So when you have 6 plus 9 is 1 billion, so 1 billion bytes. Now 1 billion bytes, okay, when you convert this into gigabytes, so it will come around around 1 GB. How? 1 billion, okay, bytes. When you divide it by, let's say, 1000, you will get 1 million kilobyte. And then when you divide 1 million kilobyte by another 1000, then you will get 1 uh, like 1000 megabyte. And then when you divide 1000 megabyte by 1000 again, which is the unit for your gigabyte, you will get 1 GB. So that is the reason why 1 million is 1 GB. So you must understand 1 million, like 6 zeros, you multiply it by 1 KB, which is again 3 more zeros. Now there are 3 set of 3 zeros, right? So first 3 sets for kilobyte, another 3 sets for megabytes, another 3 sets for gigabyte. So it's simple. So 1 million log entries, you can memorize this for all your use cases. 1 GB per day. For 30, it will be 30 GB per day. 1 million images. Okay, again the same formula here, it will run. So 1 million images, let's say 2 MB for one image. Again, you will do the same. 1 million images, right? So 1 and 60 multiplied by 2 MB. So you multiply it by, so 2 million image, 2 million is the size. 2 million bytes is the megabytes is the size for your 1 million images, right? Now 2 million megabytes, now you have to convert megabyte to gigabytes. So 2 million megabytes, now in million you have 3360. So you take 3 zeros and then convert into gigabytes. So it will be 2000 gigabyte, and then 2000 gigabyte you convert into 2 terabytes. So that's why it is here 2 terabyte in total. So always remember, for any images you have, you can just say 1 million images equal to 2 terabyte in total. 1 hour of 1080p video. Okay, so let's say you are running a video of 1 hour. So how this 1 GB per hour is an approximate number. So you can always learn this also. So 1 GB per hour, and for month you need 720 GB per month. Okay, so if you're talking about an hour of 1080 video, metadata for 1 billion rows, that could also be a very important question. Let's say you have a database table, and you in that table there are 1 billion rows, and as you know, the average size for one row in a database can be taken as 1 kilobyte. As I said, 1 kilobyte is a very standard size for a row, for a log entry, and yeah, it's like that. So now we see 1 billion, like how many zeros? 9 zeros, right? So 9 zeros, and now we are saying for one row it is 1 kilobyte. So now 1 billion meaning 90, and we are placing 1 kilobyte. So 1 billion kilobytes, isn't it? Now you just take all the three zeros and come to the number 1 terabyte. So in 1 billion, you have how many three zeros? So you have a total three sets of three zeros. So the first set will convert uh, kilobyte into megabyte. Okay, then another second three set which has three zeros will convert megabyte into gigabyte, and the last set which has the three zeros will convert that gigabyte to terabyte, and that is the reason why we have 1 terabyte. I'm explaining all this in detail, but remember, for you, you must know the concept, that is for sure. But after I'm done, or let's say after you are done understanding the basic concept behind that, you should learn, memorize these numbers like log 1 KB, rows 1 KB. Okay, then how to calculate, let's say 1 million log per day, 1 GB on an average, 30 GB per month. Similarly, 1 million images. Okay, and let's say 2 MB is the standard size we are talking about an image, then 2 terabytes. Similarly, hours, 1 hour of video 1080p, it will be 1 GB per hour and 720 GB per month. Okay, so I think this is pretty clear. Now let's go to the other cheat sheet, very important concepts. Use compression ratios. So if the system compresses data, apply a compression ratio. And how you can apply? So can compress to 50%. So 1 kilobyte will be 0.5 kilobyte. So images, wherever there are images, wherever there is a text, you can always play and ask these questions. Do we really need, we can optimize and save some memory using compression? And then if yes, then you can just apply this rule, 50% compression, make 1 kilobyte to 0.5 kilobyte, right? Image, text, all. So text, JSON or plain text, they can compress up to 70%. See, text can be compressed to 70%. Logs can compress to 50%. And similarly, for images, lossy formats, they are already compressed. But yeah, in case of images, you can also compress those images. This is your requirement. For example, let's say log compression. Using the earlier example which we talk about, for a log which is of 1 kilobyte for one log entry, finding the total 30 days log is 30 GB per month. Okay, so 30 days uncompressed log, let's say if it is 2.6 terabyte, right? Now you can say compressed logs at 50% would be 2.6 terabyte multiplied by 0.5, right? So it will be around 1.3 terabytes. So that's how it works when it comes to terabyte. uh, yeah, sorry for this text. So this was something, the format issue when I was preparing the slide. Okay. So yeah, that is for log compression, which is a very important topic. Always have in your mind when you are playing with a system problem or data system design problem where logs, images, and text are going to play the role. Discuss trade-offs. This is also very important. After sharing the numbers, now you must discuss trade-offs in storage solutions like cold versus hot storage. You should know these terms. Hot storage example, SSDs in memory for real access. Whichever system design solution or problem you are discussing, you must understand or you must ask in front to know whether the storage that you're going to implement or you're going to create in the solution is hot or cold. Hot storage always very fast, right? SSDs in memories for real-time access. Cold storage example, AWS Glacier for archival data. Sharding, which is another concept. Let's say you have a large data set. Okay, so you can distribute your large data sets across multiple servers to avoid bottlenecks. So this is also something which we can talk about. So can we distribute our data sets across multiple servers so that we avoid bottlenecks? So for example, one server which is handling, the Asia region can take the Asia region calls, another for US, for China, and all that data sets, they can be splitted, they can be sharded between multiple servers. So those are the important topics you should always have in your mind. You can always ask. Okay, so now again, I'm kind of preparing my final sheet. So log entry, just say 1 kilobyte. Text message. So let's say you have WhatsApp, right? Or any group chat messages. You can always imagine that text message 500 bytes is the standard size. Okay. And then compressed images 1 megabyte. Uncompressed video 1 GB. Database record 1 kilobyte. And similarly for 1 million units, you can easily calculate. Okay. always use powers of 10. So 1 GB is 10 to the power 9 bytes. I was telling you 1 GB, how many zeros? 9, because million has 6 zeros, right? So 1 terabyte is 12 zeros. So 10 to the power 12 bytes. So when it is called, let's say we are talking about RPS, request per second. So 1000, since scale to daily, let's say request per second is 1000. When we scale these RPS for a system wherein RPS is equal to 1000 to a daily number, so you must remember or memorize how many seconds in a day. 86,400. Now you should only focus on the zeros, which is very important. So 3 zeros here and 4 zeros here. So 3 plus 4 is total how many zeros? 4 and 3. So it will be more like 86,000 into multiplied by 1000. So you can come to a number which will be uh, you know like 4, 5, 6, 7. So it will be 10 to the power 7. So there is some mistake here. So instead of 10 to the power 5, it will be 10 to the power 3, and then and then 10 to the power 4, right? So in numbers. So that's how you can play around with your numbers. So if somebody asks you how many requests per day you're expecting in, let's say the RPS of the system is 1000 per second. Okay, it's easy. 1000 per second, 10 to the power 5, 10 to the power 3 multiplied by 86,400, which is roughly around 10 to the power 4, right? So 10 to the power 4 plus 10 to the power 3 is 10 to the power 7 is something, is request per second. Thank you very much. That was my cheat sheet for system design. In my next system design, discussions, I am planning to take real time examples of many problems where we will do in real, to understand how we are coming to a number and how we are giving answers to the final number in terms of data estimates. And I am also planning to create good series in terms of system design, more concepts, more cheat sheets, which are the foundation and the building blocks. Once we will be completing all that, then we will be focusing on important things which are connected to, for example, you know creating those system diagrams, like using Miro and other tools, because I think which is very easy, right? Very straightforward. If somebody tell you this is the way you have to draw a rectangle and this is the way you have to join these arrows, it would be easy, right? Once you do one or two times, Miro, draw.io, whatever you use. But those foundation concepts, fundamental concepts for the data estimates, for throughput, for latency and all that, they are very, very important. So in my next session, I'll be preparing more videos like that. Thank you very much and see you in another video.